Today what we want to look at are two other applications of synthetic division. Okay? One of these we're just going to cover briefly. Another one, though, you've worked with before, but I want you guys to really get comfortable using. Okay? So, the first, or I should say the second application then of synthetic division is what you see right here, the remainder theorem. Okay? The remainder theorem. What we can do, and this is what's really kind of cool, is we can use the same process that we use for division actually to evaluate a function. Okay? If you look carefully at this theorem, it says if a polynomial f of x is divided by x minus k, the remainder is r equals f of k. Alright? So, in other words, give me some coefficients. I want something x to the fifth.
4.
Okay, 4x to the fifth. How many x to the fourths do you want?
2.
Okay, so we'll do a plus 2, and then a minus 5x cubed, and what else?
7x squared.
Alright, we'll do a 7x squared, and how many x's?
Just 3.
Well, let's do minus 3x, and then we'll do a plus 1 at the end.
Alright.
Okay? So let's say we wanted to find, if this is our function, f of x, let's say we wanted to find f of, what do you want to find f of?
7.
7? Alright, cool. Because, I don't know about you, but I really don't feel like doing 7 to the 5th power, right?
So you put the 7 in
Okay.
the box and then the coefficients.
Yes. Here's the thing. If we were to divide this by x minus 7, if we were to take f of x and divide it by x minus 7, the remainder is going to equal f of 7. Okay? So whatever you want to evaluate this for, that's what you're putting in the box over here. That's your k for your synthetic division. Then you just have to 4, 2, negative 5, 7, negative 3, and 1. And here's the thing. Your numbers might get a little bit big with this, but they're probably not going to get as big as if you had to do 4 times 7 to the 5th. Okay? So let's just work through this process. This will also help us refresh our memories on the synthetic division. Remember, we add down. Oh, let me get back to a pen. We add down, then we multiply over. So now it's 28. We add down and we get 30. We multiply over. So now we're up to 210, right? So numbers are getting a little big, but that's okay. So now we're at 205. And if I multiply that by 7, I get 1435, right? You guys checking my arithmetic? Okay. If I add down, I get 1442. And if I multiply that by 7, I'm going to get, what is it, 5894?
Sure.
Come on, you're the one with the calculators.
And 5891. So.
Well, wait, what is 1442 5894?
No, it's, I got, wait, let me try one more time. I got 100,
Yeah, no.
I got 10,094.
10,094?
1,000.
Well, I mean, that would make sense because 7 times 1,000.
Oh, yeah.
Yeah, that makes sense.
You haven't done it yet.
No.
Alright, so
Logan's right.
what is it again? 10,000?
You were just a little off.
I said 10,000.
I think I had a place value moved over in the wrong spot. So 10,094?
Yes.
Okay.
So
now it's 10,091 times 7.
Which is like
is going to be 70,637.
Yes.
There we go. Plus 1 is 70,638. All right, so f of 7 is what?
That.
6,000.
So it's going to be 4x to the 4th.
What?
Oh, wait, what are we trying to find here?
Oh,
It's only the remainder.
So it's
Oh,
only
so
the
it's
remainder.
70,658.
Yeah, that's all we care about is that remainder, 70,638. Notice here it's the same process, but a different application. All we care about here is the remainder, okay? Now, you're right. If we were to actually do the division, f of x divided by x minus 7, we would have gotten 4x to the 4th plus 30x cubed plus 205x squared plus 1442x plus 10,091. Whoop, missed a 0. 91. Plus, and then it would be 70,638 over x minus 7. Okay? But we aren't trying to do division here. We're trying to evaluate the function. Okay? Now, our numbers got big, but that's just because our answer ended up being big. Alright? But it's still, you know, we were able to kind of handle that x to the 5th kind of one step at a time rather than having to find it all at once. And it can be a very, very easy way of evaluating functions, okay? But it's kind of a cool thing. We can actually use a process designed for division to actually help us evaluate a function, okay? So that's our second application of synthetic division. Okay? Any questions? All right. Now, a third application of synthetic division is, get this, we're going to factor polynomials that we can't factor. Okay? We're going to factor polynomials that we cannot factor.
If we can't do it, that we can't. You know?
So, here's a polynomial. Check this out. We have 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. And just looking at that, you know, if you tried to do factoring by grouping or some other strategy that you've learned, we don't know how to factor that. Okay? We're not able to factor that. However, we can, if we can figure out a binomial that's a factor of it, then we can actually factor it out by division. Okay? So for example, if I were to do this one first, the x minus 2, I'm going to factor out that x minus 2 so I can write f of x as x minus 2 times something. Okay? Well, factoring is just the opposite of multiplying, right? So I'm taking apart a multiplication problem, which is the division. So I'm going to do this division with synthetic division. So I put my 2 in the box. I've got 2, 7, negative 4, negative 27, and negative 18. And then I run through my process. I bring it down, times 2 is 4. Add down, times 2 is 22. Add down is 18, times 2 is 36. Add down, we get 9, times 2 is 18. And add down, and we get 0. And why is it significant that we get 0 here?
Because it means that x minus 2 is a factor.
Yeah. It means that that actually is a factor. It should factor out evenly. That's what it means to be a factor. Okay? So now, I know that I could rewrite f of x as x minus 2 times 2x cubed plus 11x squared plus 18x plus 9. Okay? Yes?
I'm a little bit confused to what you just did?
I took the original function here, wrote down my coefficients, all right? I'm using this factor right here.
Yeah.
I'm going to divide it,
Okay.
okay?
To see
And
if
it's-
it's a factor.
To see if it's a factor. Since it came out to be 0, I know it is a factor. And what's left over is the other factor, okay? I know x minus 2 is a factor. And the leftovers down here, the 2, 11, 18, 9, that gives us the polynomial that is the other factor.
Now are we going to do the same thing with the -3?
Exactly. That is exactly what we're going to do. Except, notice here, we want to continue factoring. All right?
So we just use like the one that we already did, right?
So we're going to use what we just got. Yeah. So we've got this x plus 3. So I'm going to put a -3 in the box here. Notice the coefficients I'm going to use are the coefficients from this down here. Okay? Because I want to factor the x plus 3 out of that. All right? So that I can write it like this. F of x is x minus 2 times x plus 3 times something. Okay? So I'm going to use 2, 11, 18, and 9, not the original coefficients. Okay? Because that wouldn't really help me. Okay?
Okay.
Wait, so now we do it. How would you do this if there wasn't, if it didn't say that at the top, show that those two?
Well, that's what we're going to look at next.
Oh, okay.
Yeah, that's what we're going to look at next.
What was your question?
Like, how would you know?
What if we didn't know x minus 2 or x plus 3? Where do those come from? That's what the question we're going to answer next.
So if it just gave you the polynomial and said find the factors?
Yeah, we have a process for that we're going to look at after we finish this one.
Synthetic division.
Yeah. Okay, well, let's finish this one real quick here first. We bring down the 2 times -3 is -6. Add down, we get 5 times -3 is -15. Add down, we get 3 times -3 is -9, and we get 0 like we expected to. All right, so now I know that f of x actually equals x minus 2.
You forgot 27.
No.
You take the
We're taking it from here.
coefficients from what you got of the
Oh.
yeah.
Yeah. Because we want to continue factoring. We don't want to start over factoring.
So it doesn't matter. It doesn't matter which one you start with, though, right?
No, it doesn't. All right, so now we know that f of x equals this. And notice, now we've got a quadratic, and you guys are really good at factoring quadratics. Okay? So, our final answer, if we're going to factor this completely, would be x minus 2 times x plus 3 times what times what?
2x squared plus 5x plus 3.
Okay, but let's factor that. What is it?
I can't do that in my head right
6
now.
and 1. -6. No, +6, -1.
Okay, if this were a minus 3, then yeah, that would work, but we want a plus 3, so they got to be the same signs. It's got to be a plus and a plus.
Oh,
So
2x plus 2 and then x plus 3?
2x plus
1?
1.
Or would that
2
be
and
3?
3. It's 2 and 3. 2x plus 2, x plus 3.
What times what gives us 3?
I'm shooting in the dark here.
2 times 3.
1 times 3 gives us 3.
Yeah, you're
Yeah.
right.
Okay?
Okay.
So think about it. If I put the 1 here and the 3 here, I'm going to get
Flip 'em. I think
a 6 plus 1 and get 7 in the middle. I need to get a 5 in the middle, so I've got to have the 3 here and the 1 here. So I get a 2x and a 3x. That'll give me my 5x in the middle. Okay? If you struggle with factoring quadratics, you need to go back and practice a little bit. Okay? But here's the point, okay? The point in all of this is that now with this function, I could identify all of the zeros. Okay?
Oh, yeah.
Because this is completely factored, I could say that I have zeros where? Someone give me one.
2.
2.
Negative 3.
Negative 3.
Negative 3.
Negative 1. And then I don't know the other one.
What?
Negative 3 over 2.
Negative 3 over 2. The opposite of the constant over the coefficient. So negative 3 over 2. Okay? So negative 3 over 2. And the reason why it's helpful to do that is because we can then graph this. 1, 2, there's a 0. Negative 1, there's a 0. Negative 1.5, there's another 0. And negative 3, there's a 0. What's another really easy point to find here?
The y-intercept.
The y-intercept. What's our y-intercept? Negative 18. It's always that constant term. So I know I'm hitting way down here at negative 18. Okay. Let's also think about what we've already learned here.
So it's going to be going up on the left and down on the right.
So it's, no, they're both going to go up. They're both going to go up.
Let's step through it and figure out for sure. Our leading coefficient here is positive 2, right?
Right.
Yeah.
So
Look at the original
left side's going to be up.
equations.
So
Yeah, they're both going to go.
listen, if it's positive, we're going up to the right.
Right.
And then how do we tell what the left side does?
By looking at the exponent of the leading term.
The exponent here is 4, which is
Even. So
even.
left side is the same.
So the left side is the same. If it's even, it's the same, all right? And all of our zeros have have just no multiplicity, okay? So we're going to come down here. We're going to hit this somewhere down here. We're going to come up. We try to actually hit our zeros. Okay, unlike my drawing. Let's try to fix that a little bit. There we go. That's a little better. Okay? And that's something like what that graph would look like. Simone?
Do you have a bathroom?
Yes.
No.
Yeah, that's fine.
No.
So the question came up already. What if we're not told that x minus 2 and x plus 3 are zeros? Well, we've got a test for that. And that's the rational zero test. Okay? This is something that in Algebra 2 Honors you did do some. Okay? We're going to take this and apply it, do a little bit more with it this year. Okay? Let's run through this process though real quickly. Alright? The key here is you've got a polynomial. See it. And you've got to look at your leading coefficient and your constant term. Okay? And the leading coefficient and your constant term, what's going to happen here is we're going to use factors of those two numbers to come up with possible rational zeros. Okay? Now, rational, remember, just means we can write it as a fraction with integers. All right? So, our possible zeros right here are going to be fractions that are made out of factors of the constant term over factors of the leading coefficient. All right? So, for example, on this one down here, this example 8, what are the factors of 2?
1 and 2.
Okay. And the factors of 3?
1 and 3.
1 and 3, okay? So, our possible zeros are going to be at x equals, all right, we have 1 or 3 on the top, okay? 1 or 3 in the numerator. And then we have a 1 or a 2 in the denominator. Okay? So we could have 1 over 1, 1 over 2, 3 over 1, or 3 over 2. Okay? But you also have to consider that there's more than one way to multiply things and get a positive. We could multiply two negatives. So each of these possibilities, we actually have plus or minus that value. Okay? Now, I've written these out completely. One way that, as you get the hang of it, you may write it just to kind of cut down on the writing. We could say it's plus or minus 1 plus or minus 3 over, we don't need the plus or minus in the denominator, 1 or 2. Okay? You'll see us write it that way sometimes, just to kind of save a little bit of writing. All right? So here's the deal. How many different possibilities do we have?
8.
8. Okay? How do we tell if a number is a 0?
If the remainder when you use the division is 0.
Oh god, this
Yes.
is P over Q. This
Okay?
is P over
Yeah,
Q.
this is the P over Q's. Okay?
Yeah, this takes like forever.
It can. All right? We're going to try to come up with some strategies to help you out with this. Okay? So let's start with one of these. I like to just start with the integers because they're easier to work with. All right, so let's set up our synthetic division. We're going to try 1 first. We have 2, 3, negative 8, and 3. Okay? So we bring down, multiply up, bring down, multiply up, bring down, multiply up, bring down. And guess what?
The remainder is 0.
The remainder is 0. So guess what?
1's a 0.
1 is one of our zeros. So guess what? Here. This is where I want you to think. Alright? Think. We now know that 1 is a 0, so what's the rest of f of x look like if I'm factoring this out?
2x to the second plus 5x minus 3.
Perfect. Okay? So guess what? I've got a quadratic now. Do I need to use synthetic division to find my zeros when I've got a quadratic? No. We can factor, we could use quadratic formula. Once you get down to a quadratic, unless you just really, really like this, okay, which no one does, all right, this is really kind of a pain. This process is not really designed to be fun, but it works, okay? It works, and we can find our solutions, but once you get down to where you've got a quadratic, then remember what you're trying to do. You're trying to find zeros. So at this point, you can say, oh, this is going to factor into 2x minus 1 times x plus 3. And now I know my rational zeros are going to be 1, 1/2, and negative 3. Okay? Now, depending on which ones you tried, it may have taken you a while. You might have found them on your first 3 tries, or you may have been there for a while trying them all. Okay? That's why, once you get down to the quadratic, stop. Do it the way that's most efficient. Okay? Make sense? Okay, good. You're doing great. Okay. Here's another example. We want to find all the real zeros, or rational zeros, of 10x cubed minus 15x squared minus 16x plus 12. Thankfully, since it's a cubic, we only need to be able to find 1 before we get it down to a quadratic, right? If we can find 1 of these, we've got it down to a quadratic. All right, so.
The problem is when you have numbers like 10 and 12, there's so many.
Exactly, all right.
When there's 4, that's 5.
Okay, 10. How does 10 factor?
1 and 10,
yeah,
2 and
2 and
5.
5.
1 and 10, 2 and 5. Okay, so we've got 4 different factors there. How does 12 factor?
1, 12, 2, 6, 3, 4.
Very good. Okay, so 1 and 12, 2 and 6, 3 and 4. So guess what? If there are, and each of these is plus or minus, right? So our possible zeros are at x is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, all over 1, 2, 5, and 10.
Plus or minus? Or
Well, here's the deal. If you do plus or minus on the bottom, you're going to get a bunch of repeat values. So just do it on the top or the bottom. Don't do it on both.
But it's like one, like if when the numerator's 1, like it's 1 over 1, 1 over 2, 1 over 3.
Exactly. Let's use our counting principles that we learned. How many different possibilities are on the top?
1, 2, 3, 4, 12 times.
12, and there's 4 on the bottom, so
48.
there's 48 different possibilities here, right? There's our counting principle from our last unit, okay? So we've got a lot of different chances. The nice thing is we only have to find one, okay? Here's another thing, though. Here's another thing. When you're working these out, if your numerator and denominator share a common factor, you do not need to try that one. Okay? So for example, when I'm doing plus or minus 2 in my numerator, I do not need to try 2 over 2 or 2 over 10. Why? Because 2 over 2 is 1. I already did that one. And 2 over 10 is going to be 1/5. If I started with my 1s, I already did the 1 over 5. Okay? So if they share a common factor, that'll take us from 48 different possibilities. Okay? I don't have to do the ones with 2 over 2 or 2 over 10. Okay? Or 4 over 2 or 4 over 10. Or 6 over 2 or 6 over 10. Or 12 over 2 or 12 over 10. Okay? So there's 2, 4, 6, 8, 10, 12, 14, 16 that I can eliminate just by doing that. So now we're down to only 32 possibilities.
So, what did you say? You don't need to evaluate ones with similar factors? Or?
Don't do plus or minus 2 over 2 because we're already going to end up doing plus or minus 1 over 1.
Yeah.
Right?
Yeah.
So don't repeat those values.
How do I say that in words? So I'm trying to like make a note to myself.
If the factor on the top shares a common factor with what's on the bottom, you don't need to test that possibility because it's going to repeat one that you've already done or that you will do. Okay? So, let's take a couple minutes here and see who can find one first.
3 or 5.
Okay. All right, we got a winner here. We've got 2. So Samoa, tell us what you did.
Well, I just picked 2.
How did you prove it?
Synthetic division.
Come on, talk us through it.
2 steps.
Oh, 10 times 2, 20, 5, 10, -6, and then -6 times 2 equals -12, which equals 0.
All right, good. So this is what's great about this, guys. Even though there are 32 possibilities, we only had to find one of them. Okay? You may try 31 of them and then get it eventually. Yes, there can. Okay? The nice thing is though here, once you figure out one, since this is a cubic, we could rewrite f of x as x minus 2 times
X squared.
10x squared plus 5x minus 6. And then you could try to factor that, or you could use the quadratic formula to find your last 2 zeros. You don't have to keep using this method and just guessing on things when we have a better way of doing it. Okay? All right, so anyone see how you could factor 10x squared plus 5x minus 6?
Would it just be easier to do quadratic?
Probably.
There's so many like different options.
Probably, yeah. So we know x equals 2. We got to figure out our other 2. So let's see, we'll do a negative 5 plus or minus square root of 25 minus 4ac. So that's plus 240. Okay. Yeah. All over 20. Okay. So let's see here. This would be negative 5 plus or minus 265 square rooted. And that's not a perfect square. So actually with this one, you would not have any other rational ones. That was the only one that would have worked. Okay? Because 265 is not a perfect square. That's 5 times 53. So that's actually even simplest radical form.
So there wouldn't be another one.
There would not be another one from that method. The only way to find your other 2 zeros is
So they would
to do the quadratic
They
formula.
would be, but they would be like, you know, the decimals, like interesting numbers.
Yeah, they're just irrational.
Right.
They're irrational numbers. So, but that's a nice thing. This didn't factor by grouping. You know, it didn't. There wasn't any nice way of factoring it. So we had to be able to find that one to get down to something that we could handle. Okay.
You just leave it like that?
Yeah.
Yeah. Well, it's saying find all the real zeros. So these are all the real zeros right here. There's 3 of them.
Okay. 3. So
And
then
it's plus or minus.
Yep, because plus or minus.
They used to get me like every time in algebra 2. I always forget the plus or minus.
Yeah.
Well,
Okay. So
darn.
that's basically it.